you have to go back to the very beginning of Earth's long history. The planet's atmosphere was created shortly after the Earth was formed 4.5 billion years ago. The early Earth was highly volcanic. And for millions of years, these volcanoes spewed out huge quantities of gas. Slowly, these gases built up and created an atmosphere. But it was nothing like the atmosphere we know today. This was a witch's brew of carbon dioxide, methane and steam, laced with poisonous hydrogen sulfide. There was no sign of the gas we humans depend upon, oxygen. This lethal mix was to endure for something like 2 billion years. Until something unexpected began to transform the atmosphere. Primitive life. To see how primitive life changed the atmosphere, I'm on my way to one of the very few places on Earth where these early life forms can still be found.
Just desert scrub and empty road. Welcome to the Australian outback. It's stifling hot out there. It must be, I don't know, mid-40s, but the journey is going to be worth it because I'm on my way to see one of the most bizarre sights in the world. Hey, a car! It's the first car I've seen in about 2 hours now.
The sea here is full of life. But these creatures aren't what I've come for. It's these curious lumps I'm interested in. They're important because every single plant and animal, in fact every single person on the planet, owes their existence to them.
These bizarre blobs look like boulders washed up on the foreshore, but they're not. They're actually alive. These lumps are one of the earliest forms of life on Earth. They're called stromatolites.
For all their importance, they're actually the simplest of life forms. Nothing more than bacteria. When you get up close, you can see that it's only the outer part that's alive. It's a layer of bacteria that secretes a thin film of slime, which builds up layer upon layer.
Might not look like it. These are the most successful life forms on the planet. You know, us humans have been around for a few million years. The dinosaurs came and went in 200 million years. These stromatolites have been around for 3,500 million years. That's 3/4 of the age of the planet.
And yet, when they first evolved more than 3 billion years ago, these simple life forms began the most important transformation the planet has ever seen.
These stromatolites are special because they did something that was quite extraordinary. As they took in the sunlight and photosynthesized, they broke down the chemical bonds in water, releasing something that would completely change the planet. They released oxygen.
Stromatolites were the first life to photosynthesize and release oxygen into our world. This led to one of the most profound changes in the history of the Earth. Ultimately, the planet would have an atmosphere rich in oxygen. But before that could happen, something got in the way. To see what stopped the oxygen reaching the atmosphere, I'm heading deep into the Australian outback. Although this area is dry and dusty now, 2.5 billion years ago, these rocks were formed beneath the sea. And they hold the key to what happened to the oxygen. Back then, the seas were rich in iron that was dissolved in the water. When the oxygen given off by the stromatolites met the iron, they bonded together. The result? Huge amounts of iron oxide formed, or as we usually know it, rust. It was this reaction that stopped the oxygen leaving the sea.
The rust fell to the bottom of the sea and it built up as layers. And you can, oh, this is so hot. You can see these layers right here. I mean, this is metal, that's why it's so hot. You can see the layers and the fine, colourful banding on this rock. Here, it's on a tiny scale, but on this cliff, it's on a massive scale.
The layers of rust were laid down all across the world, eventually turning into seams of iron ore. All this iron ore, in fact most of the iron ore mined across the world, only exists because very early life, stromatolites, started filling the seas with oxygen more than 2 billion years ago. But that was just the very beginning of how oxygen changed our planet.
The rusting of the oceans could not go on forever. Eventually, the iron in the sea ran out. But the oxygen was still going strong. It wasn't finished yet.
There was only one place for the oxygen to go. It left the oceans and filled the atmosphere. No event has been more important to the story of life on our planet. The first thing oxygen did was give the planet a vital protective shield, the ozone layer. It shielded the planet from lethal ultraviolet radiation coming from the sun, allowing complex life to flourish on the surface of our planet. The concentration of ozone in the atmosphere is revealed in this colour-coded image. It shows the massive hole over Antarctica created by our recent pollution. Fortunately, the hole is shrinking. But oxygen didn't only protect the planet. About 600 million years ago, it ended the long reign of the stromatolites and caused a revolution in the development of life. This is because oxygen is highly reactive and can support far more energetic forms of life than bacteria. Blessed with an oxygen-rich atmosphere, Earth became home to an extraordinary diversity of complex life. And ultimately, to us. You get an idea of how dependent we are on oxygen when you see how it affects something as basic as human reproduction. Perched between the peaks of the Andes here in Argentina are some of the highest villages in the world. Many are over 4,000 metres.